All right, welcome to the Explainer. Today we're going to dig into the surprising mechanics behind large language models like ChatGPT. And here's a little hint. It's about way more than just predicting the next word.
So let's say you give a machine a simple instruction, just like this one. Notice you're not really asking a question, right? You're just stating what you want. And then, bam, in response, it just spits out perfectly good working code. It's like it's not just responding, it's actually finishing your thought for you.
So how can a machine that's supposedly just predicting the next word pull that off? Yeah, that standard explanation, it doesn't quite cut it, does it? Unpacking that is where we find the real magic behind these tools.
Okay, so how we get to that code? Well, the journey starts with a concept that honestly seems way too simple to be this powerful.
Okay, at its very, very core, a large language model is trained on just one single massive task. Guess the next word. That's it. It's fed just an unbelievable amount of text from all over the internet. We're talking books, articles, forums, you name it. And its whole job is to learn the statistical patterns of how we humans talk and write. Think of it like the biggest game of fill-in-the-blanks you've ever seen. If the model sees Mary had a little, it runs the numbers and figures out that lamb is the most likely next word, based on everything it's read. Sounds simple, right? Well, this super simple process has some really complex and kind of surprising side effects. And this is where it gets really interesting. Because that one simple task, it unlocks some unbelievably powerful abilities. See, it's not just about predicting the words themselves. It's about what the model has to learn about the world in order to get good at predicting them.
Yeah, it turns out that to get really good at predicting the next word in, say, a physics textbook or a history paper, you accidentally have to learn a whole lot about physics and history. This is a phenomenon called transfer learning. The model isn't just memorizing sentences, it's kind of building a model of the world, almost by accident.
You know, there's a great example of this. Back in 2017, OpenAI had this project where a model was trained just to complete the text of product reviews. And guess what? It accidentally got amazing at sentiment analysis as a byproduct. To predict what the rest of the review would say, it first had to figure out if the review was positive or negative to begin with.
So this whole process creates this deep, statistical, you could call it an understanding of language. But to do any of this, the model can't just look at words as, well, words. It has to turn them into something it can work with, numbers.
So to handle language, the model uses a really cool trick called word embeddings. Now, just think of it like this. It's like giving every single word its own unique set of GPS coordinates. It turns each word into this long list of numbers, and then it places them on a huge, multi-dimensional map of concepts.
And this map is where you see the magic. It brilliantly shows the relationships the AI learns. So on this map, the word raccoon is placed really close to rabbit, but it's way, way over on the other side of the map from justice. But here's the mind-blowing part. The vector, the distance and direction from Italy to Rome, is almost the same as the vector from France to Paris. The model has learned the concept of a capital city all on its own, without anyone ever telling it what that is.
Okay, so here's a really crucial point. A model that's just been trained on the internet is super powerful, for sure, but it's what the experts call a base model. And a base model, well, it's not actually a helpful assistant yet, not even close.
You have to remember, it's learned from the whole internet, the good, the bad, and the ugly. So it can be biased, it can be toxic, it can just make stuff up. And critically, it won't reliably follow instructions. If you ask it, please write a function for me, it might just start writing about writing functions instead of, actually doing it.
Right, and as the researchers behind a model called InstructGPT discovered, just making these things bigger doesn't solve the problem. It doesn't magically make them better at figuring out what we actually want. So to fix this, they came up with a really critical extra step to align the model with human intent.
That process has a bit of a mouthful of a name, reinforcement learning from human feedback, or RLHF for short. It sounds complicated, I know, but you can just think of it as a pretty straightforward three-step training program to make the AI more helpful, honest, and harmless.
Here's how it works. Step 1. Teach it. Real human trainers actually write out examples of great answers to different prompts. They show the AI what good looks like. Step 2. Rank it. They get the AI to generate a bunch of different answers to the same prompt, and then the humans rank those answers from best to worst. And finally, step 3. Reward it. All that ranking data is used to train what's called a reward model, which basically teaches the AI to generate the kinds of answers that humans are going to like the most. So you teach it, you rank it, and you reward it.
And the results of doing this?
They're not just small improvements, they are absolutely dramatic. This whole alignment thing is a total game changer.
Get this. In one study, they took a model that was 100 times smaller than the giant GPT-3, but they fine-tuned it with all that human feedback. And guess what? People overwhelmingly preferred the tiny, fine-tuned model. It just goes to show you that alignment can be way more important than just raw brute force size.
And when you compare models of the exact same size, the difference is even clearer. Users prefer the answers from the aligned Instruct GPT model a staggering 85% of the time. That right there, that's the difference between a raw prediction machine and an actual, helpful assistant.
But, and this is a big but, this alignment process isn't perfect. It's not a silver bullet. Even with all this training, these incredibly powerful models can still mess up in really basic, almost silly ways. It shows they don't really have true common sense.
For example, someone asked one of these aligned models a simple question. What happens if you fire a cannonball at a pumpkin? Now, you and I know the answer, splat. But the model? It gave this long, wishy-washy answer about unpredictable factors like the pumpkin's material properties and the cannonball's velocity. It completely, totally missed the obvious, common sense answer.
And that brings us to the final and maybe the most important takeaway from all of this. See, we're not just teaching an AI to predict words anymore. We are actively, deliberately teaching it to follow human preferences. So the really big question we have to ask ourselves isn't just about how these systems work. It's about whose instructions, whose values, and whose intentions we want to align them with in the first place.